Welcome back. Let's set up our Curve USD Minter contract to connect with some live chain price data. And in the process, we're going to walk through a little bit about variable scope. Before we get going, a quick housekeeping note. We've previously been running all of our tests just on our local host, so you could fire up your local Ganache and be able to check things that way. Now that we're checking live chain data, we will still try and write the tests in such a way that it will give some constructive feedback, but it's highly recommended that you start running these on the mainnet fork. We're going to link some tutorial material so you can get help setting that up in case you are unfamiliar with mainnet fork, but it's great. In this case, we're going to be using these tests to actually connect with the live oracles we're fetching and compare the prices that's retrieving against the CoinGecko API. So we think that this is a much more robust way of doing it. As you can see, of course, it's both failing because we're not pulling in absolutely any data. We need to be able to fetch the current Curve USD price if we're going to be able to build a stable coin off of it. So given that this is a Curve tutorial, we're going to be using, of course, the Curve ETH pool. The Curve ETH pool is a Curve V2 pool, and if you look at the pool contract and read the contract, you can see that it contains a price oracle, which is going to tell you the current price of Curve in ETH. Super useful. Let's go ahead and create an interface so we can interact with this contract. And this is simply interface, we'll call it Curve Oracle. It'll contain one function, which is this price oracle function, which is returning a uint256. That is a view. Now we want to get this in terms of not ETH price, but USD price. So we're again going to dip into another Curve pool. We're going to look at Try Crypto, which is going to give us the ETH to USDT price. And we look at the pool here. If it was the exact same function as the Curve pool, if it was just price oracle, we could just reuse this interface. But in this case, the price oracle, where'd you go? Right up top, is asking for a parameter because there's 3 coins in the pool. You can get the Bitcoin price or you can get the Ethereum price. We'd like the Ethereum price, but we have to pass a parameter K. So we need a slightly different interface for this. So we'll set up an interface ETH oracle. And this also has a price oracle function, but it contains an argument. And then it returns our uint256. Now that we have these, let's go ahead and set up some oracle addresses. We'll call these token addresses. I'll call these oracle addresses. We'll have a Curve ETH oracle will be public. And we'll have an ETH USD oracle, which will also mark as public. No real reason, but just so people can audit it. There's always issues with oracles, and unless you're familiar with them, we don't recommend launching this because many hacks have happened from Oracle flash loan attacks. There's a few ways you could make it more robust, which is outside the scope of certainly this lesson. Now we're going to go ahead and set these 2 price oracles once we launch. Notice that we're always referring to all of our state variables with a self. This is part of the variable scope that we mentioned. Let's grab our Try Crypto address. And we have a contract ready to go with some Curve ETH and ETH USD oracles. It did not get in there correctly. Much better. All right, now we would like to have a function that is going to now return the price. So let's set this up in terms of actually having two functions. Let's have an internal and an external function. The reason for this is that we would like to be able to call this function internally, but we might externally want to just ping the contract and see what it thinks the current price is. So the external function is just going to call the internal function. Within Vyper, the big difference between external and internal functions is simply this internal decorator. If you mark it as internal, it can't be accessed elsewhere. Just like the state variables, which were declared as in the overall scope of the contract, it has to be called using the self object. So you'll call it self.internal function name. And also, Vyper requires that the internal function precedes the external function where it's called. So you might, for example, front load the internal functions up top. I'm going to create an internal view function. We'll call it price USD. It's not mandatory, but it's often seen where you'll have an underscore before internal function names. That's just a stylistic preference. And this is going to return the uint256 when we're done. So we could write this all on one line, but let's create some internal variables just to last the length of this function. And here's where we wanted to talk a bit about variable scope. So Vyper follows C99 scoping rules, which means that within the smallest block that contains the declaration, that variable is going to be visible. In other words, there's module scope. These are all the state variables. You can access these by calling the self object and pulling in any of the internal. And you have to be careful because once you've declared it as a state variable, you're not going to be able to rename that within a local variable. But other than that, the function scope is very helpful in that you can define temporary variables within it and just utilize them. And what's really nice about Vyper is the compiler is incredibly efficient. So if you've ever encountered a stack too deep error within Solidity, that's not going to happen within Vyper. So you can feel free to create as many internal variables within the function as you need. And Vyper, the compiler, is going to figure out an optimum way of making it compile efficiently. So let's create a token price ETH, where we're simply going to call the curve price, the curve ETH oracle that we defined earlier and call the price oracle function. Then let's get the ETH price in USD, which is also going to be uint256 set equal to then once we have the two, we're going to take the token price in ETH times the ETH price in USD divided by 10 to the 18th and return that. And then to verify that we're doing this correctly, we'll create an external function after the fact. It's simply going to be another view. We'll have this one called price USD. Notice the similarity. It also returns a uint256, and this is just going to pass through the results of our internal price USD function. So now if we've done this correct, when we run our tests, it should actually ping this price USD function. What did we get wrong here? Missed a colon. And the test is, first of all, going to be looking to see if it exists. Invalid argument, of course. We need to pass the argument 1 for this pool. 0 is the Bitcoin price, 1 is the Ethereum price. Once this collects, once this grabs it, it's going to be checking this price USD function, comparing it to the CoinGecko price, and confirming that the curve token price in dollars is roughly the same. And certainly it is. So we hope that you get similar good results. If you have questions about this, we went through a lot in this unit, so feel free to drop them in the comments. We're always happy to help.